All right, everybody. Welcome to another Living Freestyle Game Dev live stream. My name's Kevin. We do this twice a week, Sunday nights and Wednesday mornings right now, and it is set up like an AMA Q&A. Hop in, ask questions, generally speaking, around game dev, Unreal, blueprints, scripting, all those kinds of things, and hopefully we can stumble through those together. I say stumble because I definitely don't know everything, and Unreal Engine is crazy deep, but I am happy to try to troubleshoot or work through any questions you might have together. I am fortunate enough to work in game dev right now. I work at Riot Games in R&D. I work as a tech artist, so I have generally speaking, I have an okay foot in both the creative and the tech side of how things are rolling. And if there are no questions, which happens a lot, especially at 10:15 at night on a Sunday, that's okay because I'm just streaming me working towards my own working prototype. I look back through, I did not see any questions specifically around our last live stream. So I'm guessing, based on what I'm seeing, I don't see any questions in the chats either. We're just going to keep rolling with our game. And in that vein, we're kind of going to blow some stuff up. And I don't mean actually like grenades and stuff like that. I mean like we're going to kind of rebuild some systems tonight, and it's going to be challenging. So let's get going with that. And first we need to make sure we hop over to our Unreal so that we have that up and going. All right, and it looks like that's all working. Also, we've been having a lot of fun with the streams lately and system interrupts and stuff, so I'm going to be keeping an eye on that as we go. But what are we specifically working on tonight? Last time we left off, we were troubleshooting why one of our enemies, the 6th or 7th one, would occasionally run in. And it's a really tough thing to debug, which is why I think we're going to actually blow the whole system up. But anyways, as I was troubleshooting that, I discovered a couple other things that were really messed up and some logic that didn't make sense. So let me walk you through a couple of those things. If we bring up our shooter mannequin, we'll see the current function that is getting our rings. Let's see here. And again, some of this is left over from last session, but we were basically getting our ring. Where was it? Attack ring. Event. I thought it was in here. Drop inventory items. Change quick bar. In comma. Enhanced input. Gameplay. Possessed. Tick. Okay. Maybe that's not where it is. Let's go find where that is real quick. In our enemy behavior trees. And it's in our fight behavior tree, I believe. And in here, when it's finding a random attack location, this is going to call get ring positions. Ah, that's right. It's on the AI controller. My mistake. So let's take a look at this AI controller. All right. Here's the problem. All right. If you recall, also I discovered I have a tick. Everybody has a tick and it keeps moving. So my new one is all right. I've been saying all right a lot lately, and I'm going to be working on that tonight too. Anyways, if you remember from last time, we were drawing spheres around where our character was. And I don't know if you caught it, but every single enemy draws those spheres. Because what's happening is when we come into fight, every single enemy comes to fight, and every single enemy is finding a random attack location, and every single enemy calls get ring positions, which means that every single enemy is calling all this crazy logic that goes through and calculates all the attack positions around our hero. That's kind of pretty inefficient. And there's a lot of things about that I think we can make better. And so we're going to do that. But we're also going to do that in the and use that as a chance to learn a little bit about the performance as well, because I think it's worth doing. So right now, we do not have any crazy draws. Let's just go ahead and play and make sure we don't have any prints that would potentially affect our performance. First play of the day usually takes a while. It's 10:15, so we have Red Bull, Coke, and water. All right. We have 1, 2, okay. Reachable false. Okay, we should get rid of that reachable false. That's our usual break. Okay. And I think that might be in here. So we have 2 print strings. That's destroyed. All right. Not finding reachable. Not in here. Search everywhere. Here we go. This is in, oh, find our random attack location. And it is here. So we're just going to take this out. All right, now that we have that, let's go 10 enemies. We have 6 right now, we'll go 10. And then let's do some stuff. Okay, if we do a stat unit, that's our frame rate. Oh, we're still drawing all those lines. Yeah, that's not gonna work either. And I think that's going to be draw debug sphere. Here's the debug line. Let's skip the line. All right, here we go again. We'll keep our stat unit up. Basically, with 10 enemies, our frame time, it's already pretty slow. All right, and there it was. There was that tick. And what we're going to do is we're going to also do a stat GPU, I believe it is. All right, okay, so here we go. Base draw, slate UI, scene depth. You know, there's the other thing. You know, the other thing I want to do is I want to get rid of all these collisions. And let's do that. We'll just pick the walls. Is this all the wall? Yeah, those are the actual walls. That's not what I want. These are all the boxes. We should call these the internal walls. Let's just move these out for right now. Except for the end ones. We can keep those for the stairs. Okay. All right, hopefully that will help with, basically this is going to help with debugging later, kind of them colliding and everything like that. Right now there's a lot of colliding that's happening, so it's actually making it difficult. So I don't think the stat GPU, scene update, Lumen, post-processing, nanite. Okay, well, let's just turn that off. That game. Here we go. This is interesting. This is what I was looking for. All right. We have our world tick, and we have our tick time and our blueprint time. And just generally speaking, we're getting frame as 20 27-ish to 30-ish. Our draw is fine, our GPU is somewhere in the same ballpark, okay? What I'm curious about is if we change the way they find their attack position, does this change dramatically? So let's get rid of that. 2, 4, 6, 8, 10. There are 10 of them, but they can't settle. They're too busy bumping each other. This is just pure mayhem, okay? We're gonna keep 10 of them though. And then what we're going to do is inside of here, first step is we are not going to go through there. We are only going to come through here. I want to see if that makes a performance different first. Here we go. World tick time, blueprint time, 2 milliseconds. I don't see a huge difference here. That's okay though. We're still going to do this. I wish there was, I wonder if there's something where blueprint latent actions, player controller ticks. I'd love to know if there was a tick for our behavior trees. Blueprint latent actions. I wonder if that's something that we can look up. Hold on. So we're at 11 and 12 and 13 on world and tick time. Was that what we were at before? We go back? Ooh, undo. Yeah, it's about the same. There hasn't been a lot changed. 28-ish. I want to see one other thing. Let's get rid of stat game and let's check stat FPS. Okay, interesting. We're at 46-ish frames a second. All right, let's get out of there. Go back here and skip this all together and try that again. It's not really a super fair test because we have the interface up. You know, the cool thing is that we have 10 enemies and, you know, we're still getting reasonable frame rates. Okay, that was fun. That was, I was just curious, what I was curious about is I was curious like how much this was affecting us, but it doesn't look like it's affecting us that much, but we're still gonna fix it. All right, here it was again. How do we fix this? All right, we have our find random attack location. What we're going to do is we are going to change, we're gonna write a new ring positions. And the way we're gonna, what I'm thinking is, there are attack positions when we're ranged, and those all seem to be pretty good because generally speaking, the enemies try to find a cover point and then they'll attack from there. So the only time this is actually used is when we're melee, if I recall correctly. And what I want to do is I'm going to write or duplicate or change this so that we can create a new function, and this one is going to be get ring positions. Let's take get ring positions. Should we duplicate it? Yeah, let's duplicate it and get, oh yeah, here's why we're duplicating it. We also use get ring positions when we circle around an objective. So for example, if the enemies are going to go grab a health pack and one of them is already on it, the others will wait in rings, concentric rings outside that and take turns going there. So that's why we're gonna get, so let's do this. Let's get melee attack position. Melee attack position. Okay, and this we are going to, it's going to start off the same, but there's a bunch of things we want to get rid of in here. This is for debugging the ring positions. We're going to come in here. We're going to get all of the positions. We're going to clear those. Okay. We don't really need to cast to actor because it says we don't have to do that. We can clean that up. What we could do instead is we could do is valid. Is valid. I'm not sure when this would not be valid, but just in case, we'll do that instead. Sometimes when the game's ending and the enemies are dying, depending on the order they die, this happens. Then we're going to come through here and we're going to go through 5 rings. And for each of those rings, we are going to create positions. So this creates each of the positions. And then with each of those positions, we're going to go through and we're going to reset our ring claims. Here we go. This is all the stuff we want to get rid of or change the way it works. First things first, I think that positions could easily be created once for each controller. In this case, hold on a second. Do I have this backward? The AI controller is getting the positions around the target character. That's right. And then they're going through and they're doing a bunch of ring claims and they're checking the ring claims in all of the blackboards for all of the characters. This we may still need. So first things first is I think the rings could live with the actor itself. And what I mean by that is if we go to, I don't want to put it on the player controller. And the reason is enemies might attack enemies one day. Also, if you DC, we're going to have AI take over for your player for you until you get your internet fixed. So we want our heroes to still be able to attack. So we don't want to put it on the player controller. We don't want to put it on the AI controller. So let's put it on the pawn. And that is our shooter mannequin. And what we're going to do on the shooter mannequin is let's create a new variable. And we're going to call this attack rings. Melee attack positions. Melee attack positions. And this is going to be an array of vectors, let's say. And yep, and what we're going to do is we're going to do the same logic that we're doing here. Somehow, I got something in my eye. Where's our music? What is going on? Playing for anybody else? That explains it. All right. Whew. Okay. Okay. So we're going to take all this and we're going to put this. I think we can put this in construction. That's not construction. I think this is one of those things that we can put in construction. If we can find it. Construction script. Link anim class layers. Make sure the characters start out with a valid animation set. I think we can build this. Yep, let's try it in here. And what we're going to do is we're going to go through, okay, so number of slots. I believe right now these are set to 4. So we can get rid of, nope, undo. We can get rid of this and just go 4. So already I want this to be a variable. We're going to re-promote that to a variable. Do we need that to be local? Yeah, we can do that. Go number of slots, and let's make this an integer and a single. And then we will compile and save that. And we will set that to be here and here. All right, so we have our number of slots set, which is cool. And then the offset. Bunch of stuff. Melee attack positions. That's what we want to add to. And I believe that's everything. Now, what's this offset about? How do we use the offset currently? We're setting the offset to whatever it is if, oh, I see, if we're above 1. And then we're going to go through, but we don't use the offset ever again. It's not even used in our current one, so I don't think we need that. Is that the only place to choose? So it's basically not used. That is left over from something before. Doesn't matter which one we do. And if we're going to clean that up, that means that we don't even need to do this branch. Okay. So our offset is 60. That is bogus. And then what is happening down here that this pen is busted? Get actor location. We don't need the actor location. Actually we do, because we want these to be relative. I think we want to do relative. We don't want this to be world space. Because we're going to store the relative position to wherever we are now. Okay. Okay, but if that's the case, the actor may not have a location yet. But we don't have to worry about that. We don't really need the actor location because we're just going to add 0. So we're not going to do anything because these are all going to be relative. Okay. And then what's going to happen is we're going to add these to the positions. So the melee offset position. So this should go through and this should basically recreate our rings, but it's going to be stored on the mannequin now. And then in our hardware controller in the get melee attack positions, we are no longer going to do this. What we are going to do we don't need to do any of this anymore. This should be all gone. We don't need this ring. Okay, but what we do need to do is, what is the actor? Is this the get melee attack position is a actor to position around, which is an object. Oh, it may not. Oh, interesting. Oh, that's something interesting. Man, we may want to do this as a component. Let's just get this working first. Once we get this working, then we may end up redoing this as a component. Here's why. What if you're not attacking a character? What if there's an objective you're attacking? All right. But for now, let's just roll with that. That's the active position round. And it is a target enemy. And when we set this, what are we setting this to? That gets the target enemy. And it casts to a Lyra character. Okay, let's try it. Let's try it. So what we're going to do is we're going to take this ring around actor. We're going to get this actor. We don't actually, we don't even need to cast it to a Lyra character. We just need to get his location. Okay, that's going to work. Then what we're, oh, yikes. The hero is of a hero default, and its parent class is character default. And character default's parent is a Lyra character. All right, let's keep this simple for now. Let's go, let's cast this to a, let's see if we can, actually, let's just do this. Let's just print this string. Get display name. I need to know what this is. I'm guessing right now. And let's print the string. So when we come in here, this is going to be, wow, save that. And then inside of find random attack locations, instead of doing get ring positions, we are going to get melee attack positions. And this should break everything. Huh. It didn't print a thing. How is that possible? Get display name. Let's do the print right here then. Get display name. And let's do a print string. Print string. What is this thing? Before we go in, here's our ring positions. It's hero shooter mannequin. Okay, great. So we have a hero shooter mannequin that we're passing in, so that's going to work. All right, and then we can get rid of this, and we're going to be coming up to here instead now. And if we go to inside of our melee positions, this is going to be, rather than is valid, we can cast to shooter mannequin. And then as long as that's valid, then we can get the melee attack, get melee attack positions. Cool. And now there's a couple other things. Let's go down to one enemy just so we can troubleshoot this a little better. And we're going to bring back our debugging interface. And we're going to draw all of these attack positions. So when we come in here, if this is valid, we're going to, let's do this. The attack positions need to be, okay, this is where we need the attack. Okay, so for each of these, let's do this. For each of these, we are going to loop through. We're going to get the actor location. And we are going to add the actor location to the offset that we got when we first constructed our character. And then we're going to draw those spheres. And what is this? What is this if statement here? If it's the first one, that's what that's for. I don't mind that. That's kind of, I guess that's kind of useful. Oh no, I hate it when it does this. Whew. Okay, so get melee attack positions. We are going to do this. All right, basically what's going to happen now is we're going to pop up, we're going to come into here, and we don't need our display name anymore. It's the cast. I can't delete this. Interesting. Okay. Let's compile and save this. And close it, actually. Then inside here, bring this back. Interesting. I don't know why it wouldn't do that. Compile and save. And we're going to compile and save our find random attack locations. And then we... Bahoa. Bahoa. Is it Bahoa or is it Bohao? If it was Bohao, it'd be AO. Anyways, how are you doing? Thanks for the quick tip. Bahoa, cool. It's good to see you. How are you doing tonight? Are you working on a game? Are you just hanging out? Did you have questions that you wanted to go into? All right. So let's see what happens with this. Okay, she's not drawing anything. She's definitely going to a place. I am good. We're blowing up our enemy positioning a little bit. Okay, I'm not convinced that we're actually getting values here. So let's just put a breakpoint in this. I want to see if we actually have anything in our array. Okay, so we hit our breakpoint. Interesting. Whoa. I am just a fan of game dev streams. I have a few projects I'm working on. Game dev is hard. Mainly game design. Glad to hear. That's cool. Well, I appreciate you stopping in and saying hey. Okay, so we're clearing this, and then we're casting to here, and then we're coming up into here. And it looks like our melee attack positions are bogus. I think that's what's happening, which means that possibly doing this in construct is not the way to go. So let's try to double check and see. Also, why didn't she hit this breakpoint already? I would have expected her to hit that breakpoint already. Oh, wow. It's because our actor to position around is unknown. What in the world? How is that possible? Unknown. Okay, we got a bigger problem here. Oh, because I'm a genius and I forgot to connect it. Okay. That's always good. Connecting the pins, always good. All right, let's try that again. Yeah, I look, I'm not gonna lie. The R&D is like one of my favorite things because every day is a little bit different. Especially depending on which phase you're in of the game, and I think that's one of the things that I like about it so much because, for example, when you're in prototype phase, for some reason, it's still not drawing straight. When you're in prototype phase, you know, I mean, I would go to work some days, and your team's small, and you have to do everything. You get to wear a lot of hats, which is a lot of fun, and so there were days where I would go to work and I would be doing C++ engineering work. There were days that I would go to work and I mean, I did visual effects for almost 6 months straight because the team didn't have an effects artist and we needed effects. And so I learned a ton about VFX and everything that goes into it. I had a blast doing it. Some days I was animating, there was just no end to it, which was just, it was a total blast. I had a great time. Let's put this breakpoint back in here. I want to see what these values are. Sure does seem like, what is in, there's nothing in our attack positions. All right, that's sort of what I was suspecting, which means are we going into, where's our hero shooter? Here's our hero shooter. Are we doing this? Is this stuff even happening? Melee attack positions. Close on spawn, instance edible. Replicated. We would need to replicate this. For sure. I used to be a database engineer for finance a long time ago, and as there were cool aspects of it, but there were also, I mean, at the end of the day, I'm not gonna lie, game dev's a lot more fun. All right, let's go none. I'm not convinced I'm coming in here, so let's put a breakpoint here. I'm not sure that construction is the right place to do this. Yeah, we're not even hitting that. Is it because, yeah, dude, we're not even hitting this. So let's change where this is happening. Let's take all this logic and then we'll put this on begin play. Just to make sure we're actually doing this. Event begin play. Listen for teams, set the actor hidden game, show the spawn. And we're going to put that in, let's create a new event. Or no, let's create a new function. And we'll call it setup melee positions. And in here, we're just going to execute all this stuff. And then we will pop this in. Yeah, that's not an order. Oh yeah, for sure over the next 1,000. But you know, there's also something that's really nice about you know, making a thing, working with your hands and stuff like that too. Okay, so this is all gonna run now, and we just need to make sure we call this function set up we need to set up our melee attack positions. Let's rename this setup melee attack positions. And we're going to do this on begin play, which was here. Begin play, doing all the things. Set up melee attack. Compile and save. Oh, it didn't like that. It did not like that. Number of slots. Oh, because I made that a local variable. Promote to local variable. What? Undo. Let's change the name of this thing to number of slots. And that should cover us. Does not like that. We'll just feed that in here. Get rid of that. Hold on a second, we broke something. Our 360 is not even connected anymore. Let's go back and look at what that was connected to in our ring positions. Number of slots, 360 is connected to the offset. So that wasn't even used? Okay. I guess we don't need that anymore either. Destroy. Cool, this is just getting simpler and simpler. All right. All this looks relatively pretty. Let's see if we have attack positions now. Still not printing anything, which is a bummer, but we're not giving up yet. In our melee attack, we're coming into this for each loop. And do we have attack position? We have no attack positions. How is that? Somehow we still have no attack positions. Okay, back to what we were doing before. Are we actually coming in here? Are we actually ever hitting add? I didn't see it hit add. Did you see it hit add? No object selected. Play. No object select. It's not hitting it. Okay. New plan. Why in the world would it not hit it? What? Okay. So are we not calling begin play? We have to be calling begin play. That doesn't make any sense at all. None of this makes any sense at all. We should be hitting this right off the bat. Here's begin play, okay? Is pawn ready to initiate? Okay, we're never getting there. Because, okay, we need to move where this is happening. Obviously. On pawn ready to initialize, show pawn next frame, set visibility. Okay, this is where we need to do this. That's why. And this is show pawn again next frame. La-di-da-di-da. It does all its stuff. It sets the actor location. I think show pawn again next frame. I think we want to do this right here. Okay, here we go. This is gonna work. Can feel it. Here's begin play. There we go. So now we're setting our attack positions. Okay, we're still not drawing anything. So even though we're setting our attack positions, we're not actually adding anything. Here we go again. Play. Here we go. So we're going from 1 to 5. We're going from 0 to... Whoa, 0. Numbers... Oh, come on. We didn't set our default value for number of slots. That's why. We need 4. File and save. This time, we're totally going to work. I keep saying this time it's going to work. One of these times. Eventually, I'll be right. Right? Yes. Okay, cool. Whoa. It's a little excessive. Okay. Now let's eject and take a look at this. This is working. And that is a lot of melee attack positions. We don't need that many. That is for sure. Okay, but we finally made a step in the right direction. So we're drawing all those. All right, let's go back and reduce this. We only need like 2 rings of melee attack positions first off. Let's see how that looks. There's just not going to be that many people attacking melee. Doesn't make any sense. If we eject out, that's reasonable. I think that is a reasonable melee attack range. I could see maybe one more if like you had long distance attacked. I think we're going to add in I think we're going to add in the ability for like a dash attack, things like that. I could see making this bigger, but we'll do that later. Okay, so we have this being set in our default mannequin. That's great. And we are no longer using getting the ring positions in here. We're not setting the move to location because we're not actually doing that yet. Because we need to actually do the work. In here, this is basically, it gets the melee attack positions. And then for each one, it draws a sphere. Okay. We do want to update our positions, I believe. All right, here's what I'm thinking. Okay, maybe we can use a whiteboard. Wouldn't that be crazy? We use a whiteboard. I'm gonna draw this for you all. All right, this is what I'm thinking. Let me make sure you all can see this. Okay, so this is our hero, or our player, okay? These squares are our attack rings. And let's do this. Let's make this a little bit more. Okay, so this is our hero. The squares are our attack rings. And then our enemy, let's make our enemy pink. Here's what I'm thinking. This is our enemy. Now, these attack positions are kind of predefined. They just ride with the character wherever they go. But what we don't want, and the problem that we were having in the last stream, if you recall, is this character, if they were the first one to get an attack position, they would always run around to attack position 1. And they always attacked from the same spot. So every single time there was only one enemy on the screen, if your hero was facing this way, yikes, your hero is facing this way. I'll try to make this into an arrow. Right? Your hero is facing this way. Oh, look at that. I guess that's this way. The enemy would always attack from this location because this was the 0 location. So it went 0, 1, 2, 3, for example. So the first enemy always attacked from 0. Super boring. This is what I'm thinking now. What I'm thinking now is we take and we get, here's our hero, here's our enemy. We're going to get this vector, right? There's a vector that's defined here, from here to here. All right, and what we're going to do, did it again. What we're going to do is we're going to normalize that vector. And when we normalize that vector, that's going to give us a direction. And then what we do is we find the closest spot along that vector so that this enemy will run to here, not all the way around. And then in the case where the enemy is sitting over here, they would come to here and so on. The idea is they're not running around the hero. Now, where this gets fun is if we have 2 enemies right behind each other. Maybe they're coming through a door or something like that. We're going to have to deal with the case where they're going to get the same vector normalized. If this attack position is already claimed, they need to go to the next closest one. This is the logic that we're trying to wrap our heads around right now. And so that's what we're going to try to do in Blueprint. What time is it? in the next 10 minutes. It's not happening. Not happening. But this is the madness that we're working towards. All right, so first things first. We need to store the positions, kind of like what we were doing before. We cleared it for each one. We're basically just going to add, we're just going to, nope, not that kind of add. We're going to add to the array for each one. And what we're adding is the position. All right, so now our enemies, let's move our debug out of the way. But what we want to add is we don't want to add, do we want to add that? Let's think about this. Maybe 30 minutes? But I appreciate your vote of confidence, but my brain already hurts trying to think about the vectors, okay? But anyways, all right, so we have the positions. Do we store the positions? Or do we store the added positions? Let's store this, okay? And then when we're done, what we're going to do is we're going to go through each of the positions. We're going to check the ring claims. That's fine. That's still the same. We may or may not do this. We'll come back to that in a second. And then for the attack ring claim, oh goodness gracious. Set all the current claim values. Oh, I see. Okay, so this is the initialization. This is the setting of the values. And then what we're going to do okay, so Boho is saying, I like the look at node. Use a location vector and drag off. It should show up on a look at search in context sensitive searching in Blueprint. Yes. Yes, that would work. I mean, the look at might work, but let's just see. I'm curious. What is the look at? The look at function. That's the animation one. That's not the one you're talking about. Look at function rotator. Find look at rotation. Interesting. Okay. I don't think that's the one you're talking about either, but we'll get to that in a second. All right, so we have our positions. We're going to go through. We don't have a good claim, so we need to get one. All right, this is where. Okay, so this is where we pick one. And the positions we're getting is an array index. And this is where the flaw was before. Basically what it did is it came through and it went through each of the ring claims. And if the ring claim was less than 1, it was free. And we could use that. We want to change the way this works. Just let's make sure we're in a melee attack. Okay. What we want to do, this is sort of confusing because this is here. We're going to set the array element that we're going to break out. And we're going to go do that. Okay. I'm going to delete this. I'm going to delete this because it hurts my head to look at it like that. There's just so many things going on here. This is why we're simplifying this. My ring claim is bogus. That's not what we want either. Okay. So let's forget about all this ring claim stuff and let's just do the vector stuff we were talking about. All right, here's what we're going to do. When this is complete, we have the actor location already. That is the actor that we're going to be attacking. And then we need to get actor location. Get location. Nope, come on, man. Self. Get a reference to self. Get the location. The AI controller BP does not. Okay. Self. Nope. So many things. Self. Let's try this again. Eventually we'll get it. Self. Here's what we're gonna do. We'll do self. Then we'll get the controlled pawn. Get the controlled pawn, which I don't think we already have, but let's just double check. Player state, components, transformations, root component. Whose root component is that? We might be able to use this. Actor, pawn. Yeah, we don't. No, we don't have pause. Pawn. Nope. Okay, so this is that, and let's get the actor location. All right, and then all we're going to do is we are going to take our position, and our, what I mean is the enemy, and we're going to subtract off the hero. That's going to give me the vector that I was talking about. And we may do this the look at way that Bahoa is talking about. But for right now, because my brain has to work straight ahead. So we get our vector, then we're going to normalize it. Normalize it. And this is going to give us a position. Now, interesting. I am going to multiply this by 50 right now. And let's just start with small steps. Let's change this pen to a float and make this 50. And I'm going to draw, right here, I'm going to draw a debug sphere. And we're going to make it center point here. Let's make it red. And let's make the radius 50. Well, duration of 1, thickness of 1. Okay, so at the very least, at this point, we should have a red circle where this guy is hopefully going to go for their attack. What? Oh, actually. Interesting. Something broke. Positions we're adding. Oh, because we have to add in, okay, well, duh. We forgot to add back in the target actor position. So we need to add this in so that it's relative to our target. That's the vector math we were missing. Because that was basically just putting a point 50 units from the origin. And 50 is too small. So let's make that 150. That's interesting. Okay, it's definitely moving. That is definitely working. So that vector position is working. It's finding a spot that is basically, yep. Okay, and it's changing. You can see it changing as the character moves. All right, so we have a spot. That's cool. Now, if we take the normalized vector, here's my question. I want to print this. I want to see what the number is. I also only want, I don't really want the Z component of this, but let's just print this anyways. .51 hold on a second. If I'm over here, that position, you think we could just round it? So if we were to round that number, that would be -1 and 0. And our first position point is back behind us. -1, 0. If we go over here, our value is 1, 1, almost 1, 1. No, it's not quite 1, 1 because there, now it's 1. Actually, it's -1, -1. That makes sense. If she's behind me, is it, what is it here? 1, 1, okay. And then here would be 1, -1. Okay, those are the coordinates of the spot that we want to choose in these cases, because remember, we have these 4 points around our character. The problem is those positions, I wonder what are those positions? Hold on. We have our positions. Could we go through, okay, this sounds nuts, but if our position, what are our position coordinates look like? When we come through here, when we add this, let's print these. I want to see what these numbers look like. Okay, we're going to print these. And we're going to print these red. 2 seconds should be enough. Let's see what kind of numbers we get. Okay. Our positions are not normalized. That's why. But they're 75, 129, minus 129, 75, 75, 129. So basically you can see them kind of bouncing back and forth. So let's change this. Let's store normalized numbers for our positions. And that was on the hero shooter mannequin. If we take these and we get the rotator and we're adding in 150. Why are we doing that? We make a rotator, we're multiplying by 150. If we don't do this multiply, and we just add these spots in, we're going to be rotating the vector around. Okay, rather than multiplying by 150, we want to multiply by the index. So that way the first one is normalized. Yeah, I love wild ideas, Bahoa. I am so open to recommendations. But basically what this is going to do, to finish off my train of thought while we wait for Bahoa's wild idea, is this is going to store normalized vector positions around any character that we can use as melee attack position. And then what we can do is, based on those, we can use those to get the coordinates and then set our attack ranges based on player size and attack ranges. Okay. Add sockets to the character root and have those sockets be the locations. They'll update on transfers. That's true, they will. And the thing that might be tricky with those is they would also rotate with the pawn. And if they rotate with the pawn, because maybe, well, there's two things about it. One, obviously, if you, depending on where you attach the sockets, if you attach them to the root, for example, they'll rotate with animation, any animation you have on the root. And if they're not, if they have the pawn and you change to pawn facing, now they rotate. So what happens is, and I think we did this once before, I think that's what our initial thing was. So what would happen is if our character turned to the left, all of the enemies would try to reposition themselves to be left just because the character turned in place. So by doing this, it's independent of the character's facing. Okay, so let's take a look at what we got now. Actually, I'm pretty stoked that the stream is holding up as well as it is. Okay, see, look at these numbers. These numbers are way better. So the first set of numbers is 0.5, 0.8, 0.8, 0.5, 0.5, 0.8, okay. There is a way for us to make these zero-based, but I think the principle could be the same. So here's what I mean by that. I think the idea is we just find which of these is closest to this attack position that we're looking to get. And then based on that, that's the one that we choose. Here's the thing though, calculating all of this information, I have a dumb idea. What if I rounded all these numbers? You could also add a target points to the actor they don't render in game. Can add an actor tag to them to easily get them when needed. Yes. But this is kind of what we're doing on the fly. We're actually adding these points. The problem isn't so much adding the points. The problem is picking which point you go to. So in this particular case, I have the points. I'm happy with where they are. We saw them draw earlier. And I just want to pick the best one. And to pick the best one, I'm trying to find a way to do that without calculating it. So what I'm trying, and to be more specific, these are all awesome ideas, but what I'm thinking is, what would be really cool is if I can magically, let's just make this simple, okay? Let's just say these 4 points here align to -1, -1, and this is -1, 1, and then this top one is going to be 1, 1, and this one is going to be -1, 1. All right? If by chance this character, this bad guy, is standing right here, and we get a vector to our hero, and the point that comes back is, let's say the point that comes back is -0.8 and 0.7. If we round that and we get -1, 1, then I know it's this one. I don't have to do any math. I'm just like, oh, I just go to -1, 1. And what and there's also, like, we could do, so without doing any math, I know where to go to, but more specifically, imagine that these positions are not, imagine these positions are in a 2x2 array. Okay, so right now they're like, we're thinking about it in space, but imagine these aren't, this isn't in space. Imagine this is a 2x2 array. So in a 2x2 array, with all of your points, we've got 3 points. We're going, actually, let's just simplify this. We're going to go 2 points in a 2x2 array. This index, the index of this item is going to be 0, 1. The index of this item is going to be 0, 2. And this is going to be 1, 1 and 1, 2, right? If we take this whole thing and recenter the array by subtracting off 1 from each one, basically the idea here is this assumes you're standing here, but we're not, right? We're going to be standing in the middle. So if all we do is imagine this is the position, And so effectively, in order to get this up, we're going to have to subtract 1 this way and subtract 1 this way. So if we subtracted 1 or 2, whatever it is, then we're going to get this point will become -1. You see what I'm trying to do? But because the point is, once I'm rounded and I get this -1, 1, I don't have to find anything. It will correspond directly to an entry in my 2x2 array. That should be possible. For some reason, my head's just not thinking about it. But let's just go back and do the rounding. Let's see what happens if we round this. Okay, so we're going to take these points, and for the attack positions, we don't care about Z. Let's take this value, and can we round? Is there a round function? Round. Nope. Let's break this. Nope, that's not what I wanted. So this is a rotator. Then we're going to rotate the vector, and we're going to split. Nope. I thought there was a split. Here we go. Split the spin. Okay. So we're going to take this. Can we round this? Yes, we can. So we're going to round this. We're going to round this. We're not going to worry about Z because we don't care about Z right now. All right. And then we're going to, there it was again. I keep saying all right. Let's make a vector. Make a vector. An int vector. Sure, why not? Nah. Let's just keep this as we're doing. Let's make a vector. And what we're going to feed into it is our rounded values. And with each of those rounded values, we're not going to be doing, what is this? Ah, yes. We are going to be multiplying those times our deal, and we're going to add those in. So now, thank you, Baha. You were right. I couldn't break the link because it was connected. Okay, so now when we do our print, our red values will be, look at that. So we have, hold on, I can't even read them. They're so fast. Let's try this again. 1, 1, -1. Dude. All right, we need to increase that print time. Or we could just look at the message log, which is, where did our message log go? Where's our output log? Output log. Okay, so here's what it's print. How's that around? Oh, okay, okay. So if we go back to the beginning of this train, wow, there's a lot of this. So many of these. Okay, so there's an easier way to do this. Whenever we see a decimal, that's when it starts. Okay, so here's our decimal. So we have 1, 1. So if we're looking at that from above, 1, 1. Then we have -1, 1. So these 2 points, if we come back to our chart, which is getting nuts, let's find the eraser, man. This is kind of crazy. Let's get rid of all this now that we know what we were doing. All right. All right. We're almost there. Okay, so the points we're getting are, we got 1, 1. So visually, that's 1, 1. We got -1, 1. 1, 1, -1, 1. Then we have -1, -1. So this is -1, -1. And then we have 1, -1. 1, -1. That's pretty cool. We have the 4 points we're expecting, or we're hoping to get. Then we have 2, 2. Oh, this is interesting. So then we have over here, we're going to go 2, 2. We have 0, 2. That makes sense because we have an extra position here. Then we have negative 2, 2, which is negative 2, 2. And then we have negative 2, 2, and we have negative 2, 0. Negative 2, 0. Cool. Negative 2, 0. And then we have negative 2, negative 2. Dude, we have all the points we want. This is perfect. Negative 2, negative 2. And we have negative 2, 0, which is this one. Wait. I must have gotten one of these wrong. Oh, 2, 0. 0, 2. Negative 2, 0. Negative 2, negative 2. 0, negative 2. 0, negative 2 is what I read that wrong. 0, negative 2. And we should have a 2, negative 2. 2, negative 2. Here it is. 2, negative 2. And then the last one we're missing. Excuse me. The last one we're missing is 2, 2, 0. We already got. Thank you. 2. Yeah, this isn't 0, 2. This is 0, 2. I spelled that wrong. 0, 2. And then, so we have all of our points. This is perfect. We have 2, 0. That is definitely not the right pin. 2, 0. Okay, so we have all of our points. This is great. Now that we have all of our points, what we can do is if we take this is printing all of our points. This is great. So we know these are good. Then what we're going to do when we're complete is we're going to print a string that is the vector. Okay, let's take a look at that. What was the string that was printing for our decimal? The string that was printing for our decimal. What happened to our output window? It disappeared. Here it is. Would have been -1, 0. I don't know if that's the right position, but let's just try it. Let's just try and round that and see what happens. So if we take this value and just like we did, we don't even need to, yeah, let's just round it. Okay. So we're not going to multiply by 150, but we're going to take this value normalized and we're going to split it. And then we're going to round, and I'm not going to type all this stuff again. We're going to copy all of this and come back here. Okay. And then we're going to connect these in. And we're going to make our vector. And then okay, so we're done. Wait. We've completed our loop. We're not going to print this string. I'm not going to worry about that. What I am going to do though is now that we're done, all these are in position. Oh, look at this. I can do it all at the same time. I don't even have to do it separately. If I figure out this vector beforehand, I can do this while we're going through our positions. So let's see here. What we can do here, I'm going to keep the positions just in case. I'm not sure why yet, but we're just going to do that. And I'm not going to worry about adding this. What I'm going to do is I'm going to take this and I'm going to say equals. If that is equal to this, and that is true, that is going to be, let's just draw it. If that's true, let's take that. Okay, let's go the full tilt. Let's take we're going to take that value we're going to add 150 to it and they'll draw a debug sphere. And then this goes to where? So we can reconnect it. So this should only draw a red debug sphere if the position, not sure what that's doing, but we'll figure that out in a second, is there. I'm going to come down here. All right, so we're going to fill positions and we're going to be adding just the straight value. Okay. All right. Whew, gosh, my brain. And we're definitely way past time, but that's okay. Okay, so what we're going to do is we're going to come in here. We're going to fill all our positions just because we're going to do it. And then we're also going to check to see if they are equal to this rounded position. And if that's true, we're going to multiply by 150 and we're going to add that to the original actor location. And then we're going to draw a debug red sphere there. So we should only get one debug sphere. I don't see any debug. Oh, look, there was a spot. Did you see the sphere? Interesting. What? I'm wondering, they would have been smart to print this out. We didn't do this. Because I'm curious what numbers it's comparing right now. Okay, there we go. That worked. Like it found one that was equal. So if I'm there, it's there. If I'm there, it's there. Okay, this is kind of working. Okay. Okay, so it's working. Now when it's not working is when I'm straight in front of her. Why? This is the one we need to figure out. But we're close. We're close. And the reason is, yeah, this is what, okay, so let's take a look. Let's do a couple things. First, let's go back to Be Hero Shooter Mannequin. And rather than doing, we don't need this. These are all of our melee attack positions. Compile and save. There's definitely, was that an error somewhere? Oh well, I didn't see it. Nobody saw anything. Okay. These are our positions. I want to print string. All right, so let's check. Let's print a string. And the string we're going to print is going to be this. But actually, that's not all we're going to print. We are going to print for each one, we're going to print this as well. And we are going to append these together so I can see. So we're comparing the first number that prints is the attack position. The second number that prints is the thing that we're comparing against. And let's just make that 4 seconds. And let's roll. All right, this is gonna have to stabilize. Whoa, look at that. All right, so when he's in front of me, where are you going, buddy? You are comparing, here we go. We're comparing 110 to -10. 1, 1, 0 to negative 1, 0. Negative 1, 1 to negative 1, 0. Okay, so it's always negative 1, 0. And of all of our attack positions, none of them, okay, this is why. Okay, this makes sense. It's because we only have 4 positions. And the problem, oh gosh, okay, we figured it out. We figured it out. Here it is. Let me draw it for you. The problem is this. We only have 4 attack positions. So when we are straight in front of our character, this spot right here, this spot right here, these aren't actually attack positions. We don't include these because originally we didn't include these originally because they were too close. The enemies would kind of get on top of each other. Also, what would happen is enemies, if we had another enemy that was here, this enemy would be in the way and it wouldn't attack. So the idea was we would get rid of this as an attack spot. And the great thing about that is if another enemy was back here, they could use a ranged weapon and shoot between them. That was the original thinking. Holy cow. All right. So one way we can solve this is we could just add these positions in and then it should just start working. And it might be cool to see what happens in that case. The other thing we could do is if none of those work, we could try incrementing this so that they get the 0, 2 position as an example. All right, but now we know what's happening. Okay, which is great. So let's go back to the shooter mannequin, and we're only using 4. And the problem with 4 is, hold on a second. Number of slots 4, and it's the number of slots times the index. What if we just always made it 8? And what would happen is in that case we would have 2, 3, 4, 5, 6, 7, 8. We would have this. Oops. Our attack positions would be this. And then we'd have a whole nother set that lived like this. You get the idea. It's interesting. I don't hate it. I don't hate it. Let's just try it. Let's try it. Let's just see what happens. Okay, so rather than number of slots multiplied by the index, let's just make it 2 every time. So that way it's always 8 right now. This is a super weird kludgy. Yeah, I'm not worried about invalid anything. All right. So what's going to happen now? Look at that. You see that? Oh my gosh, it totally worked. So he's going right there. Okay, if I'm over here, that's the point that he's choosing. If I'm over here, that's the point he's choosing. Oh my goodness, this is cool. I think this is cool. A lot of times I think something's cool and later I find out it's not, but in my mind, this is working. In my mind, this is working. All right, so here we go. Positions, this is all the printing. I'm gonna say that this is working now. So let's get rid of our print statements, clean this up. And then what we need to do is, if this is true, we want to set this to be our attack position. And if this is true, that's the one we want to claim. That's also the spot that we want to claim. This is setting our ring claims to, this is resetting our ring claims. Set my ring claim to get values int. And then this is doing what? Sets all the current ring claim values. Okay, fine. And then this goes my ring claim. Yes, this is what we want to do. Okay, I think this is overly complicated way down here. So let's just, if this is true, we are going to say that my ring claim we're going to set it to be this index. All right. And we don't even need, we're not going to draw the sphere, I believe. Okay. So that's our ring claim. Now the trick is that is not the same as our position. That's okay. So we're going to set our ring claim, and then this is going to go through all of the claims. Let's not worry. Okay, let's just keep that there. For each loop, ring claims completed. This is getting my ring claim. It's all the actors, sets all the current values, and then positions my ring claim is valid. La-di-da-di-da. Interesting. Okay. All right, well, we need to, so, okay, here's the deal. Here's what's happening. Let's say I've already claimed a ring position. Like I've already claimed an attack position. If I'm moving and the hero's moving, I don't want to constantly be updating that, because I'm going to get into all kinds of fighting with my allies about, it's just going to basically ping pong back and forth between the ring positions and things like that. So if I make a claim, that's where I want to go to and attack from. So what I want to do here is, I think I need a separate variable. And this my ring claim is current, and basically what I want to do is in here, if my ring claim is bogus, then I want to use the new one that I've constructed. If my ring claim is still good, then I still want to keep going there. So the attack ring claim gets the value as an int. Then we're going to get all the actors of class. We're going to set all the current ring values, unless hold on, we need to look at this for a second. That's not even connected anymore. Okay, so we're going to go through, we're going to set all the ring values. This is not even used. We're going to get the owner. We're going to get the blackboard. We're going to get controller. And we're going to set the ring claim values. Target, and we're going to make sure it's the same target enemy so that the ring claims are relative to the enemy. That makes sense. Then when we're done, we're going to take our positions. We're going to look at my ring claim, and we're going to see if that is a valid index. And if it is, then we're going to, wait, what? if my ring claim is a valid index, why are we saying we don't have a good ring claim? Go to the next one. Hold up a second. I just got lost. If my ring claim is a valid index. Oh. If my ring claim is less than 0, this should never happen. That's never going to be true. That should be false. So it's going to come down here. And then it's going to check to make sure that the position is able to be projected on the nav radius. And if it is, it's going to come down here and it is going to return what is it going to return? This is our drawing of the lines, positions, gets, move to location. Ah, so that's going to set the move to location. And it's going to get the attack ring claim because theoretically we've set it somewhere above. Okay, positions, yes, but remember, yes. Okay, have you ever used blackboards and behavior trees? You can lay out a simple state tree to do this loading. Yes. Okay. Actually, all of this is running on a blackboard behavior tree. So here is our behavior tree that spawns this whole fun. And you may have missed this early on, but basically within this behavior tree, what's happening is we get to a point where we basically get to a point where we check to see if our melee weapon is equipped and whether or not we should melee effectively. And if we should melee, we'll skip this. Otherwise, we come in here, and this branch here gets attack positions for ranged weapons. And the way that works is it does exactly what you say. It uses an EQS, and it finds cover points that they attack from behind, and they'll pop up and down and stuff. All that stuff works. So where we are right now is we're in the melee tree, right? Do we have a melee weapon? And if we do, we're finding this random attack location, which is a little misleading because it's not really random. Dude, no apologies. This is not an apology thing. It makes total sense, and it's actually a really good question. So basically, in the behavior tree, if we're melee, we're trying to find a melee attack position now. Random is misleading. We need to rename this. But like I said, we're blowing everything up. So now that we're finding our random attack location, we were getting ring positions, and we're actually changing this. So this is all kind of part of a behavior tree. The problem with using an EQS for this particular thing is well, wait a minute. Is it a problem? It might not be a problem. We might be able to use an EQS. Shoot. Can we do this with an EQS faster? All right, let me explain to you why I was thinking it was a problem. The problem with the EQS is there was no way to specify whether somebody had already claimed that spot. But that's not true, because we do that for our ranged positions. Okay. All right, well, first off, this totally works. Let's see, though, if we're going to blow this up again. So if we're going to blow this up again, what does that look like? The way that looks like is... So here's our EQS, which finds the cover position for attack. if we go and we look at this EQS query, the way this looks at it is it does distance to query, path exists. So this would actually solve the closest point problem if the EQS was given points around the character. That's true. But we want to generate cover points in playable is what we're looking for. Okay, so let's find that. Generate cover. Generate cover points in playable. All right, what this does is, oh gosh. Specifically, I don't want to go into all this. What I'm specifically looking for is I'm specifically looking for the part where it doesn't collide with its enemies. Okay, so these are the cover points. Then it does a line trace. Then it generates the points and it sets those. Then for generated points, enemy destinations. Look at this. This is what we're doing. We have a clear destination. We set it as clear, and then we go through each one. And what we check is we check to see if what? Oh, okay. Enemy destination. All right, so what we're doing here, okay, this is wild. Let me see if I can explain this to you. How this works, Bahoa. I think you may have just blown up my whole world, though. All right. So the way this cover points thing works is, what it does is, no, in a good way. All in a good way. Everything's all in a good way, right? So basically the way this works is, it takes the enemy, and in this case, I'm going to use enemy as somebody on another team, all right? So it looks at the enemy, and then what it does is it generates an EQS set of points behind obstacles that are away from the enemy that they could shoot from as cover points, okay? So if you had, this is going to be easier if I draw this. All right, so let's move this over, and let's draw this like this. If this is the, nope, let's just use a pencil. It'll be easier. Okay. So if this is the enemy, all right, and this is me, or not me, I mean the person who's doing the thinking, the AI, for example, all right, and this is a wall, and this is a wall. What it does is it basically looks at the vector from this way, okay? And it basically generates fans like this, kind of like normal generate cover stuff does. And then what it does is when it finds it, it hits something like this point here or this point here, what it does is it takes a point behind and it generates a fan like this. So behind each of these points, it's actually generating 3 points. And it says, bingo, these, not green, let's pick a different color. These 3 points are possible locations. And these 3 points are possible locations. Because they are all away from the enemy I'm trying to shoot, behind an object, and I can shoot from there. Now, which of these points will I go to? And basically what happens in here is, it says, this is the standard 180 degree fan from the Centroid. That's what this is. So this generates the actual cover points. So here's our generated points. And then what it does is for each of those, is these enemy destinations. Well, where does enemy destinations get set? So enemy locations is cleared. Generated points is cleared. That's our known enemy stuff. Enemy locations. Enemy destinations. Let's find our references. Where does this get set? So what it does is it grabs the enemies. It looks at their move goals. If their move goal, so it goes through all the enemies, it sets their move goals. If their move goal, this is what's happening here, if their move goal is within a certain distance of this point, then that is not a clear point for me to go to. So if I had, for example, 2 enemies, and I'm going to draw, just call them the same teammates, right? Let's say I had 2 people here, all right? This character decides they're going to go here. This character is going to say, it's going to check there, and it's going to say, nope, I can't go there, so I'm going to go here instead. That way, they don't clash. So if we use this exact same logic, basically, to do this, we could get around all of this 1s and 0s and 2s and 1s and everything. But I want to be clear. Our 1s and 0s and 2s and 1s is working. I'm just thinking that this is probably a better way. Good job, Bohoa. Is it Bohoa or is it Boa? Because you used a snake. What's the snake for? Literally, all we would have to do is run an EQS query around the ally and then rerun this exact same logic. Just get the enemy destinations, make sure nobody else is going there, and then that would be it. That would be, yeah, but that's why this is so cool. That's why it's so cool to have people here to offer other outside perspectives, because the feedback, it's just like anything else, feedback makes you better. Oh, it looks like a snake. I need glasses. Yeah, I love snowboarding, dude. Snowboarding's awesome. I never could skateboard though. Something about hard ground, leaving skin behind, that's just not my thing. Snowboarding, loved it. Skateboarding, I just, hurt so bad. But I still skated. I just was awful. And I just didn't like leaving skin behind. Okay. So can we just blow this whole thing up and just run an EQS query for the melee attacks too? I think we can. I don't think we're going to do that tonight. I think we're going to call it. Because I do have to go to the day job in the morning and I can't be a total wreck. I like that. Good job, Ahoa. Thanks for hopping in and helping me think outside the, from a different perspective. That's awesome. I'm going to keep our find attack location around because it was kind of a cool exercise. It was totally a cool exercise. I think it totally worked, but let's just kind of go ahead and wrap things up here. Okay, so again, thanks for hopping in. Anybody else who was hanging out in the wings, thanks for stopping in, and also on YouTube. I'm happy my machine didn't die during the stream. That was great. As always, if you have questions or comments, throw them in the comments. If you have something that you would like to cover, our next live stream will be Wednesday morning at 8 o'clock, 8 a.m. Pacific Standard Time. We do these twice a week. The YouTube is, here, I can paste the YouTube channel in the chat as well. Let me find that real quick. We basically dual stream. We stream to YouTube and Twitch at the same time. And the YouTube stuff gets recorded and posted so you can kind of reuse and do again. So let's see here. I may not be able to get there while that stream is going. Let me try on a different chat real quick. Live in freestyle. Where is it? You know what? I should just have this as a thing that you can pop up. Here we go. I think it's, I guess they've changed the formatting of it, but here's the YouTube link for you. Anyways, so the next live stream is going to be 8 a.m. Pacific Standard Time Wednesday morning. We do these Sunday nights and Wednesday morning. Thanks for stopping in. Throw your comments, any questions you might have, or just hop in the next stream and let's just kind of go over whatever it is together. As far as where we are with what we were doing today, it was actually a really fun exercise, a lot of brain vector work, but in general, and one of the great things about doing these streams is, you know, as we saw, I think we have an idea for a better way to do this. So I'm going to keep all the stuff that I've done here for figuring out these positions, but I like the idea of trying to do this with the EQS system instead, and we're just going to reuse our logic. So we will probably be doing that Wednesday morning because I got to get some rest tonight. So as always, thanks for hopping in. Thanks for checking it out. I hope you all have an awesome start to your week, and I will catch you all on the next stream. Take it easy.